Good morning, class. You are welcome to today's class. Today's we'll be looking at lecture 7, and the topic here is error and exception handling. So we will be looking at error and exception handling in both Python and PHP programming language. Error, we might have been, as a programmer, trying to write a program for the first time. There is no way we will not come across error. So when you are writing codes, mistakes are almost inevitable. They are almost inevitable, especially when you are writing code for the first time. And this mistake, we call it error. And they can be error can, they can be virtually, it is virtually impossible to write code without mistake at the very first time. And with this this error, trying to writing code and bringing out error. So it's now grouped into three main types. So they are basically grouped into three types of error. So whereas we have syntax error, semantic error, and logical errors. So semantic errors, so they are the errors that have to do with using the wrong code, and usually it's a result of typos. So they are caused by wrong code or typos, and when we have that, our program won't run. So our programming code will not run when we have such kind of error. That's just kind of syntax error. So it's that kind of error, it's common. So I believe programmers writing code very well will always come across syntax error. So, and syntax error, I told us that there are mistake in how the code is written, which we call the typo. There are the mistake in which how the code is written, that is the grammar of the language. So, and what causes is often maybe the typos, the wrong spelling, the missing bracket or missing symbol. So what causes syntax error? So the IDE may even point out the error by highlighting the errant code and displaying an error message. So we can see, because I still write code recently, that I come across syntax error. So the IDE will always highlight that errant code. The IDE will point out the error by highlighting the errant code and displaying an error message. So it will display an error message and also point out the error by highlighting the errant code. So, and I told us earlier that it's caused by wrong spelling. Wrong spelling when you want to type something and it's not the same exact thing you want to type, maybe wrong spelling. So it's a syntax error will come and generate so in wrong spelling like that. So, and we have misplaced delimiters. Misplaced delimiter are some of the more common ones. So misplaced delimiter, so those are the things that cause syntax error. I told us as well, missing bracket too, it can cause syntax error, or misplaced symbols as well can cause generating syntax error, whereas our program won't run. So that is for syntax error. Though we have done that in 201, but just to recall us, or for us to still remember what you are doing, and we're able to compare it with that of the Python with PHP as well. So we have another types of error that we have is semantic error. Semantic error, we have discussed about syntax error. Semantic error we want to look into. So semantic error occurs because the meaning behind a series of steps used to perform a task is wrong. That is, the result is incorrect even though the code apparently runs precisely as issue. So in this semantic error, the code will surely run. The code you are writing will surely, if you run it, will run. But the meaning or logic is incorrect, so leading to wrong result. So the meaning or logic of that code, the meaning or logic is incorrect, but the code will run. So that meaning or logic that is incorrect leading to wrong result. So that is for semantic error. And semantic error are tough to find. They are tough to find. You can't, not like syntax error that you can easily see in your, when you are writing your code and there is an error, it will bring out semantic error. We can as well come across syntactic error. But semantic error, they are tough to find. They are tough to find in our coding, and you sometimes need some sort of debugger to find them. So there is a need for us sometimes need some sort of debugger for us to find semantic error. So, but that's why I said earlier that in the explanation that the code will run, but the meaning or logic is incorrect. That's leading to wrong results. So that is for semantic error. So let's see another type of error. And for example, now let me just cite an example of semantic error. So like for example now, if your code is supposed to add numbers, maybe 2 numbers, but it subtract them instead. So the effect is that incorrect output, even though the program worked technically. So the output will be incorrect, despite the fact that your programming worked technically, but the output will be incorrect. So that is the effect of your, maybe a code that you're supposed to add 2 numbers or add number, but you subtract them instead. So the output will be incorrect, even though the program worked technically. So that is for semantic error. So and it caused the step in the program in the program that doesn't it step in the program don't make sense for the intended task. That intended task you want to accomplish, the step in your program will not make sense. It won't make sense. So that is for semantic error. So, and I told us earlier that it doesn't used to, it doesn't used to occur, like that occur, maybe, it's tough to find. It doesn't occur regularly as you are writing your code, not like syntax error that you can as well see frequently, come across it frequently as you are writing your program in your code. So that is for semantic error. We have discussed about syntax error and semantic error. So the third type of error we'll be looking at is logical error. So logical error, I will say they are the faulty developer thinking. They are the faulty developer thinking, often related to incorrect use of operators or assumption. So a semantic error, logical error occur when the developer thinking is faulty. When the programmer, that is the programmer, the developer, their thinking is faulty. That is how logical error occur. So, and in many cases, this sort of error happens when the developer use a rational or logical operator incorrectly. However, logical error can happen in all sorts of other way too. So now, like Some developers don't create a division between semantic and logical error, but they are different. They are different. Semantic is different from logical error, but it's just that the developer, they don't create a division between the two, semantic and logical error. Like a semantic error that I've explained earlier occur when the code is essentially correct, but the implementation is wrong, such as having a loop executes once too often. So whereas logical error occur when the developer thinking is faulty. So we can see here that logical error is different from semantic error. So and like the difference in that, like I said it earlier, the difference in the semantic error correct code structure but wrong step meaning. That is what semantic error occur. That's how it occur. That's what it does. It corrects code structure but wrong step meaning. That is for semantic error. But for logical error that we are looking at is a flawed reason, is a flawed reading or misuse of operators. So sometimes, our operator may not be correct. We can misuse it. So logical error occurs in such a case situation like that. So and as well, if misuse, maybe loop as well, misuse of loops or maybe our loops, the way we structure our loop or the way you write it, maybe it's misuse of writing it or misuse of structuring it. So the loops or formula as well, some formula that maybe you didn't write it correctly, so logical error occurs in such a case like that. So that is for logical error. So error are usually detected during the testing phase of software. So during the testing phase of software, error usually detected. So error are usually detected during the software testing phase. So since the program refuses to run or give wrong output, there are special constructs that are specifically for graceful handling of error. That is, the error is detected without crashing your code. So which we will be looking at exception. So we'll be talking about exception. So how to specifically, gracefully handling of error. We have special consoles that are specifically for graceful handling of error. That is, error is detected without crashing, without your code being crashed. So which we'll be looking at now, which we have exception. So exception, what are exceptions? Exceptions are errors that occur during run times. To exception, they are the errors that occur while a program is running. So when your program is running, exceptions are errors that occur. So yeah, I will say they are runtime error. They are runtime error. So and handling an exception with a try statement is called caching an exception. So caching an exception means examining it and performing a response. That is the meaning of caching an exception. You examine it and possibly doing something about it. So the art of detecting and processing an exception is called error handling or exception handling. So you take note of that. So when we say error handling or exception handling, is the art of detecting and processing an exception. So in order to properly detect error, you need to know about error source and why error occur in the first place. So there is a need for us to know about the source of error source, and why error occur in the first place in our programming. So for us to properly detect that this program, this code I'm writing, there is an error there. There is a need for you to know the source and why error occur in the first place. So when you do detect the error, when you now detect the error where the error occur in the first place, you must process it by caching the exception. So there's a need for you to process when you have detected the error, for you to process it by caching the exception. So that is for that. So now the exception, from what we have said, there are special type of error that occur while the program is running. I've said it, they are the runtime error. So for example, let me just give us example of exceptions. Maybe for example, maybe you are dividing anything or any object, anything by zero. Dividing by zero can cause exception. So an exception can occur in that. Another example is trying to open a file that doesn't exist. Maybe you are trying to open a file that you have not already, it has not already located or already in the memory, or assigned to one particular, assigned already to a variable. You have not declared that type, that data type, or any, or that that variable that you have not already assigned or declared. So it can and trying to open, you have not already assigned that file or declared that file, or maybe it's already in a file already existing already, and you now try to open a new file or a file that does not exist. So exception can occur. So, and as well, another example I can give for exception is accessing invalid indexes in an array or list. So that is it. And the problem in exception is that if not handled, if exception is not handled, the program can stop immediately. Your program, the program you are writing, can stop immediately if exception is not handled. So that is for exception. So let's see an exception handling. Now I've said it, to avoid the program crashing when an exception occurs, we catch it and handle it gracefully. So by using try and except block. So for us to like syntax error are easily highlighted by Python ID for correction. So that of the syntax error, we have three types of error, that we have discussed earlier, which we have syntax error, semantic and logical error. But that of syntax error are easily highlighted by Python IDE for correction. So other errors are not immediately detected by the IDE, can be detected by the following mechanisms. So we want to look at the other mechanism that we can detect, a error. So we can detect other error. So whereas which we have the try and except block, So those are what we to for us to avoid our program being crashing when an exception occur. So we use try and except block in Python. But in PHP, whereas we'll be moving there after treating Python, maybe next week we move there. So in PHP we use try catch block, but in Python we use try except block. So the try except block, there are any block of code that might cause error is placed in the try block. So any block of code that might cause error is placed in the try block. So Python starts by executing the sequences of statements in the try block. So and if all goes well, skip the except block and proceed. If an exception occurs in the try block, Python jump out of the try block and execute the sequences of statements in the except block. So what the purpose of all what here is that, all what we are saying is that for the try and except block, the purpose is that it handles code that might cause an error without crashing the whole program. That is the work of try and except block. So it handles code that might cause an error, so without crashing the whole program. So instead of the whole program to crash, it will handle the code. Try and except block, it will handle the code that might cause an error. So and how it work, how try and except work. No, Python try to run the code inside the try block. So we'll see it from the example here. So Python try to run the code inside the try block, and if no error occur in the try block, the except block is skipped. So if there is no error that occur in the try block, the except block is skipped. So it's skipped in except block. And if an error occur in try block, if an error occur, Python jump to the matching except block. So let's see it in the example here, using try colon s equal to int, inside the bracket, the first bracket raw underscore input, enter a number, close with the two brackets, print s. So we now use except because an error occur for the try block. So except, so it now goes where it, so for, because an error occur, so an exception occur in the try block, because an exception occur in the try block in this example. So Python now jump out of the try block and execute the sequences of statements in the except block. So like in the except block, which is except value error, it said print please enter a value number. So you now supply a value number. So for example now, like this example now, for example you type, maybe you have a number, you type 5 as a number, you understand, you enter a number like 5, so it print 5, you understand. But for instance, if you type this alphabet ABC, you type it shows, it will now shows, it will show please enter a valid number without crashing, without your code crashing. It will tell you please enter a valid number. So that is what this example is trying to tell us, how to use try and except error block. So another one is raise statement. Raise statement. So raise statement allow the program to force a specific exception to occur. That is what raise statement do. It allows the programmer to force a specific exception to occur. So the purpose of raise statement is manually trigger an exception when it detects a problem, when it detects a problem yourself. So it manually trigger an exception. That is what raise statement do. So it allows the programmer to force a specific exception to occur. So it manually trigger an exception, that is raise an exception when you detect a problem yourself. That is what raise statement do. So raise statement, like for example, this example of raise statement. So like this, the same code, try s int raw print s, raise, this where we use raise statement, raise value error. So except value error, print please enter a value number. So the usefulness of this one is that when it's useful is that when your program detects something wrong, that Python won't normally treat as an error. So when your program detects something wrong, that Python will not normally treat as an error. So raise it raise statement occur. So that is it in this one. So when your program detects something wrong that Python will not normally treat as an error, so raise statement occur. So that is, for example, e.g. invalid user choice. So raise statement occur. So that one we look into finally. Finally is another um is another exception, is another way of handling exception. So that is finally. Finally, there's also time when you must ensure that the code handle an exception gracefully, even if that means shutting the application down. So Python provides the finally clause, which always executes even when an exception occurs. So you can place code to close file or perform other essential tasks in the code block associated with this clause. So the purpose of finally is that code inside finally always run whether or not an exception occur. So that is the purpose of finally. The code inside finally will always run. We always run if whether or not whether an exception or there is no exception occur, code inside finally will always run. And it typically used for cleaning up actions. So clean up actions like closing file, releasing resources, and saving log. So that is the typical use of finally. So it's clean up actions like closing file, releasing resources, and saving log. So let's see the example, the same code example for finally. So s equal to 0, try s equal to int, raw input, enter a number, print s, except so except block, value error, please enter a value number. So finally coming, finally print the value of s is s. So assert. So that assert here, it tests if a condition is true during execution. So that is for assert here. So now the behavior for this example code is that, for example, even if you enter a wrong value and get an error, the value of s is still that value of s is still that s is still the value of s, and that value of s will still be printed. So if you enter a wrong value and you get an error, that value of s that you enter will still be printed. So that is for finally. So let's see another. We have multiple kind of exception, and each one's name reflect the problem that occur, and when possible the condition under what it can happen. So Python provide a wet or standard exception that you should use whenever possible, and these exceptions are incredibly flexible, and you can even modify them as needed to meet specific need. So we have major ones for exception, for major common Python exception that we can always come across, or there are some that we are familiar, that we have been coming across. So we have the common one and the major ones they are listed here. They are the exception, that is the exception, number one exception, that is base class for exception. We have another one, stop iteration, raise when the next method of an iterator does not point to any object. And another one, system exist, raised by the sys dot notation exists portion. We have standard error, that is base class for all built-in exception except stop iteration and system exit. We have arithmetic error, that is base class for all error that occur from numeric. We have overflow error, we have floating point error, we have zero division error, we have assertion error, we have attribute error, we have EOF error, we have import error, we have keyboard interrupt error, we have lookup error, we have index error, we have key, we have name error, we have unbound local error, we have environmental error, we have IO error, we have OS error, we have syntax error, we have indentation error and system error. So that we have been, some of it we have been coming across, like that of the syntax error. I know programmers in the house we have been coming across that syntax error. So we take note of that. So by next week we'll be looking into PHP error and exception handling. And that of we have the system exist as well, and type error, value error, runtime error, not implemented error. So next week, this week Thursday, in another lecture we'll be looking at error and exception handling in PHP programming language to compare with that of the Python we have treated today.